we are team number 3. We are going to present our STEM project that is Hydrogen Mini Creator. Our teammates are Reyes, Jose Luis, Sara, Santiago, Ale, y yo. This is our index. We are going to present our development about the system, the introduction, the problems, the CG, the solutions, the applications, and
So, this project focuses on developing a small cost hydrogen generator using magnesium rods and vinegar as the reactor system. And the goal was to explore a simple low-cost method of producing hydrogen gas and understanding a chemical and mathematical principle behind the processing.
Our problem is that many people lack of access to clean or affordable energy, making them to rely on traditional fuels, which pollute the air, affect some people's health, and increases climate change. Many of us, as students, we don't have access to explore or research these kind of sources, like the clean energy, because of this kind of problem.
The SDG that is related to our STEM project is the SDG number 7, that is affordable and clean energy, because it emphasizes on generated clean energy through a simple and low-cost method, and helps students to learn more about and experiment with sustainable energies.
Our solution, what is our project, consists of a low-cost hydrogen generator, which is a safe and elastic reaction to prove how sustainable energy is using basic materials.
The specification of our project is that hydrogen is one of the cleanest fuels available, and understand how to produce it safely and in small quantities allows students to learn more about renewable energies, about chemical reactions, and the potential of hydrogen technology. And the object is that this project is designed and test on a hydrogen generator using vinegar and magnesium, and through a simple chemical reaction. Through the project, we are going to measure the quantities of hydrogen and the reaction of the process, and understand how this method can be a low cost for generating renewable energies. Our methodology, first we want to know the reaction, so we first investigate about how can we generate the hydrogen. Next, we have a project before this, but it doesn't work, so we select another project that then was this, and we select the materials that were the magnesium rods, the vinegar, the container, and we assemble a prototype to collect the gas. So then we measure the reaction rate and the quantity of hydrogen produced. The reaction rate was, the first was fast, it was like a quantity of 1 liter hydrogen, and then we record the observation and difficulties. This is our prototype name, the hydrogen mini creator.
Okay. So our prototype is a sealed container which contains foods. Magnesium rods are covered with vinegar to allows the hydrogen gas produced to be collected or jerked into a balloon. This is a safe, fast, and simple reaction, and it allows visual production of gas bubbles.
Now, theoretical framework. The chemical topics are first the acid and metal reaction. It means that the magnesium reacts with the acetic acid, releasing the hydrogen gas. The second topic is the gas formation and stability. This means that the amount of hydrogen gas that will go from the prototype depends on the moles of the magnesium and of the acid. My topics. The first one is the proportional relationships. This means that if we use more magnesium or more strong acids, then the reaction of the gas will increase. The second topic is the Bayesian measurements. This means that we estimate the 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 volume of the hydrogen gas that we will get equal depending on the magnesium. Yeah.
Well, a prototype works when the vinegar touches or comes in contact with the magnesium nuts, making the acid react with the metals, producing hydrogen gas. And a hydrogen goes to a tube that can be collected or stored. The system still works. The system works as long as there is enough magnesium left to as long as there is magnesium and in the vinegar is strong enough to continue the reaction.
Well, this is a results about we have the hydrogen bubbles that we collect in that the container, and this is the speed of the reaction. The effectivity solution. It was like a fairly effective because we before have a method that we used, but it didn't work because of the cables don't connect very well with the battery that we have. So we have to change, and this is we changed, and it was not the original plan, but we have this alternative more effective.
Now the feasibilities. Our project is feasible because we use low cost and easily accessible materials such as the magnesium rods, vinegar plastic containers. Our project is also feasible because the assembly of the prototype was very easy. We didn't need any special or professional tool to assemble, and it's also very feasible because for the reaction we need a room temperature, so you can do it in any setting from the school or even in your house.
Its benefits are it's low cost, the materials are really not that expensive, it's easy to assemble so everyone will recreate it at home. It promotes the understanding of clean energy, it's a safe experiment, and lastly, it encourages experimenting, measurement, and scientific thinking.
One of the improvements that we could do in our prototype is that we use a pure magnesium or changing how strong the acid is to get a better hydrogen, or add a pressure meter or changing to a better container to store the gas better. And another one is that we could mix the seal so that we can avoid any leaks. And last one is that we could test other acids so that we can compare to obtain a better hydrogen.
What we learned during the development of this prototype, we learned a lot of things. First, we learned about how the chemical reactions can create this hydrogen gas. We also learned about how to assemble the prototype so we can have a good result from this project. We also learned about how to search and look for information and for more things to develop the project. And last but not least, we learned about how to make a good problem solving as a team.
The difficulties, as I mentioned before, first method didn't work, so we had trouble about that, and we have trouble also to controlling the electrical connection of the detergent, and we have to change this one in the stage 3, so it was difficult, and also it was difficult to measure the exact amount of the hydrogen that is collected. And before, in the beginning, the reaction was fast, but then it was a little bit lower because of the hydrogen, the magnesium rods were like a little bit old or a little bit warm.
So, in conclusion, this project helps us understand how hydrogen
can be produced and why clean energy is important. Our fifth method didn't work, and we use in this method a battery and electrodes. So we change it to a simple reaction with magnesium and vinegar. And the second method is produce hydrogen, and it shows us that clean energy can be made with basic materials. And we also learn how energy, how to work together and solve problems and keep trying. And when something doesn't work as we plan, and keep trying. And in the end of the project, the project reached its goal and taught us more about science and SDG 7, which focus on clean and affordable energy.
This is references. Thanks. And now we have
What is this again? It's more about what?
these are the magnesium rods, and this is all the hydrogen particles that are and it's a little bit slow now because of the magnesium rods are like a worn and old and was used too many times to experiment, so it's a little bit slow, but now this is how can I prove that the hydrogen is in there. And it has a bad smell if you just...
You should be very careful, you know, at this moment to just put up a pop.
Also, it's inflammable, so just don't get in the fire because it would explode. It happens, so it happens to me. It's not a good option.
I don't know that. Lisa is a little bit nervous. She's a little bit worried about something that it will explode or anything. But that's okay. Nothing's going to happen, right? Okay.
Not now. It is, if you touch it, it's a little bit like a hot because of the reaction that it has. It has a reaction to produce the hydrogen, so it's normal. If you put it in a little time, it can explode because of the heat that it has.
So did you experiment that before?
Yes, I experiment that it explodes, so
It's pretty good. So if you take half of the reaction, it should be outside.